Greetings everyone, this is Mr. Mall, and today I'm doing a podcast on Nomenclature Rules E, and this is going to be taking a acid and turning a name into a chemical formula. So we're going to go ahead and get started here right away. So first off, when I'm looking at turning a name to the formula for an acid, we first need to realize that acids are going to be only nonmetals, and the clue when I'm looking at a name that is an acid is it's going to be ending with the word acid. This just means that H plus hydrogen is the cation. So when I have acids, I have two types of acids, and I've just named them oxyacids and hydroacids. And how do I know the difference? If I don't see hydro at the beginning, I know it's an oxyacid. If I see hydro at the beginning of the name, then I know it's a hydroacid. So let's go ahead and take a look at these two rules, different rule sets for naming acids. Okay, so let's talk about oxyacids first. Like the name, oxyacids have oxygen. So the steps to do these is we have to look at the polyatomic ion, because most of those polyatomic ions have oxygen in them. So we're going to take the 8 or 8 ending polyatomic ion, and we're going to pair that up with the correct number of H pluses. A phrase that I find very helpful to remember how to turn these into a formula, and I'm going to show you how to use this in a second, is I ate some icky OxyClean and got the itis. Okay, I ate some icky OxyClean and got the itis. Kind of a weird phrase, but it's going to be really helpful if you can remember this. I have the OxyClean as the thing I ate to help you remember that this sentence applies only to acids with oxygen in them, or oxyacids. So let's look at this nitric acid. I know it's an acid because it ends in the word acid, and I see this ic ending, and that starts with nitric acid. Okay, so I'm looking here. I know it's an oxyacid because it doesn't start with the word hydro. I know it's an oxyacid. So I'm going to go ahead and use this set of rules. I'm going to use this phrase, I ate something icky. So I look at the ic ending, and I look at what's paired up with it, and it's nitra. So the ic is going to tell me that I need to look at the anion that ends with ate. So what starts with nitra and ends with ate is nitrate. So I look at nitrate, I find it on my polyatomic ion sheet. It's NO3 minus 1. That is my anion. So now what I need to do is I need to pair that up with the correct number of H pluses. So I find H plus, plus 1 charge, negative 1 charge. I only need 1 hydrogen. So my formula, if you want to, you can cross the charges, is 1 H and 1 nitrate, HNO3. Nitric acid, done. Let's look at another example. Nitrous acid, I know it's an acid, it ends with the word acid. I know it's an oxyacid, or it has oxygen in it because it doesn't start with hydro. So I'm going to my polyatomic ion sheet, and I'm looking for that 8/8 polyatomic ion. So to find it, I look at us, nitrous acid, and I remember that I ate some icky OxyClean and got the I to us. So when I see that us ending, I'm going to look back, and I need to look at the anion that ends with ite. So I look at nitra and add the word ite. Nitrite is what I'm looking for. Find it on my polyatomic ion sheet. Nitrate is NO2 minus 1. So now what I need to do, I take this 8 polyatomic anion, pair it up with H plus. I have 1 H plus, 1 nitrite anion. We have a neutral compound, HNO2, nitrous acid. Okay, let's go ahead and move on to the other type of acids. Hydroacids. So hydroacids do not have oxygen. Okay, you're not going to see any oxygen, and you know it's a hydroacid because it literally starts with the prefix hydro. So the only step for these is we have to pair up an anion that ends with IDE with the correct number of H's. So I'm going to go ahead and look at my acid here. I know it's an acid, ends with acid, it's hydro, so there better not be any oxygen in my formula. So I look at hydro and I see this nitra. So what anion ends with IDE and starts with nitro? Well, this is just nitride. Okay, nitride. Now, if you recall, all endings, IDE ending anions most of them are just regular old nonmetals. A couple of them, like cyanide, peroxide, hydroxide, those are going to be kind of exceptions, but most of them are just regular nonmetals. So the regular nonmetal that starts with nitra is nitrogen. So I look up nitrogen on the periodic table. I take its group number -8. Nitrogen likes to form a -3 charge. That's my anion. So now what I'm going to do is I'm going to pair this up with hydrogen H pluses, but I must have enough H pluses to make a neutral compound. So I have a -3 charge. I need 3 hydrogens. Here's my final formula. If you wanted to, you could even cross the charges here, do that little trick. And the 3 is going to become the subscript of my hydrogen. Hydronitric acid, there it is. Let's do another example. Hydrocyanic acid. So I know it's an acid, has the word acid in it. 8, that means H plus is going to be the cation. I see that word hydro, so I know that when I get to the very end, there's no oxygen in here. So I'm looking at cyan. So I'm looking for the ide ending anion that starts with cyan. Well, this is cyanide, but cyanide you're not going to find on the periodic table. So I'm looking at my periodic table sheet. I remembered that was a polyatomic ion sheet. I remembered that was one of the ones that I had to memorize. Cyanide is Cn-1. So I pair up an H plus because it's an acid, and I only need one of them. Hydrocyanic acid, HCN. Done. This is how we turn a name to a formula for acids, and I hope that this was helpful.